Good afternoon, everybody, for whoever's joined, and thank you for joining today's webinar. My name is Rabcevskis, and I'm the product manager here at Terabee for our level monitoring solutions. Just for your information, we are recording today's session just so that we intend to make it available to you afterwards. I'm joined today here by my colleague Krzysztof Zurad, also a product manager and our lead expert in LoRaWAN. Hi, Chris.
Hey, Rob. Thanks for having me.
Hey. If we just flick on to the next slide, we can have a look at the agenda. So I'm going to start with giving a few words about Terabee for those who do not know us yet. And then Chris is going to really dive into the world of LoRa and looking at differences versus other wireless protocols, demystifying what LoRa versus LoRaWAN is, looking at architecture, different types of networks, frequencies all around the world, range opportunities, also limitations, and the different types of classes for devices. And then we're going to look at a very particular use case with a LoRa-powered sensor. And also we're going to leave a few minutes for open questions if you have these during the session. Just a reminder about this, feel free to use the Q&A section in this webinar to leave your questions during the session, and we'll clearly be glad to answer them after the webinar. So about Terabee. Terabee is a sensor and sensing solutions company, and we built our core expertise around 4 areas. Number 1, that's optical time of flight. And on the one hand side, we have single point LED rangefinders, and on the other hand side, we have 3D depth cameras. We also have experience in infrared thermal imaging cameras for heat detection, but also ultra wideband technology with an example used for positioning systems in GPS denied environments. We do have a strong team of physicists that design, develop, and manufacture our own sensor modules, meaning that we understand very well the technology and the physics behind what we do. And based on that, we've also developed what we call application products in a number of market verticals, as you can see, including level monitoring, smart buildings, sensors for Industry 4.0 and mobile robotics, and also specific solutions to mitigate the COVID-19 situation. You can clearly read more about our products and solutions on the Terabee website, but for now, I'm passing the mic to Chris, who will dive deeper into the world of LoRa.
Thanks, Rob. So let's now focus on the main topic of today's webinar, which is LoRa, LoRaWAN, and all the basic concepts you need to understand in order to deploy a successful application. So I would like to start with a simple question. What is LoRa? LoRa is one of the wireless technologies available out on the market. As the name might suggest, it stands for long range, which means that you can transmit a signal over the long distance relatively. It's also important to mention that it works in unlicensed spectrum, which means that essentially everyone who has a LoRa device can transmit or receive data over a LoRa network. And also it's rapidly growing worldwide. Now LoRa becomes one of the major IoT technologies available on the market, and it's here to stay for sure. So in order to better understand what kind of pain points LoRa solves, we need to look at this simple graph. On the x-axis, you can see the range, which means essentially how far a given wireless technology can transmit data. On the y-axis, you can see the bandwidth, so how quickly we can send this data with a limited amount of time. And let's start with Wi-Fi. Wi-Fi has been with us for a long time. And Wi-Fi is a great technology, but it works only on a very short range. That's why it's very common in consumer IoT applications, for example, smart home. Similarly, there is cellular technologies. Cellular technologies have been with us also for a long time. Rob, can you go to the next slide, please?
Sorry. Thanks.
Yeah, thanks. And they also can address applications from short to long range with a high bandwidth. But unfortunately, the cellular applications require lots of power, and many IoT applications cannot have that power limitations. And this is where LoRa comes into play. LoRa essentially works with short range and long range, and it works with low bandwidth. But at the same time, it works with a very low power. And that's why it's a perfect fit for many IoT applications.
Chris,
okay.
before you move on, to all the attendees, if we can just ask to mute themselves and mute their microphones, just so there's no background noise, and Chris can focus on the webinar. Sorry, Chris, and thank you.
Thanks, Rob. All right, so let's move forward. So let's try to answer a simple question. When and why is LoRa the right choice for you? And what are the suitable use cases for LoRa? Let's take an example, long range. Imagine that you are a farmer and you would like to monitor moisture levels of your soil. You're probably gonna be located in the rural environment, so you're gonna have very limited access to network, for example, 4G. You also would probably have a big area, so farms are usually pretty big. So you want to have a long range and ability to support long range with LoRa. On the other hand, let's look, for example, on a smart city application where you would like to, for example, monitor the parking spaces in the city. You will probably want to have lots of parking sensors all around the city, and you don't want to change the battery every 3 months. So you need to make sure that your wireless technology is optimized for the power, and it can last on the battery for many years to come. Those two applications I just mentioned can also, what is also important is that the sensors that they use are low cost, because if you start having lots of sensors in your application, you will very rapidly increase the cost if the cost of a sensor is high. Also, thanks to LoRa, the operation of those sensors and the wireless technology is quite cheap. So that's a good thing to keep in mind. And finally, there is the low bandwidth. The biggest limitation of LoRa is that it cannot send many data over a short period of time. But most of the applications I just mentioned do not need this frequent updates. So if you have a sensor in a parking lot, you don't need to send every second. It's sufficient if you send the data once 15 minutes or an hour or a day, the same on the farm. And on the other hand, we have technologies that are not suitable for LoRa. If you need to send real-time data, if you need to send photos or watch Netflix, probably LoRa won't be the best choice for you. Okay, let's move on to the next slide. So many people use words LoRa and LoRaWAN interchangeably, but it's not exactly the same thing. And I would like to a bit explain what are the differences. LoRa has been invented and patented by Semtech. And the major role for LoRa is to essentially transform zeros and ones using LoRa modulation into a waveform and send that waveform over the air to another unit. LoRa uses different frequency bands, as you can see at the bottom, and I will talk about those frequency bands a bit later in the presentation. If you remember from school the Open System Interconnection model, the OSI model, LoRa would be at the bottom of that model in the physical layer. And then on top of that, we have next layer, which is LoRaWAN. And as the name suggests, it stands for Long Range Wide Area Network. This layer focuses on defining different classes of devices, class B, A, C, and also the protocol and network itself. So it essentially dictates how the messages are being transferred inside the network. And if you look at the OSI model, it would be the second and the third layer in OSI model, referred as MAC layer. Okay, great. So now we know a bit. Yeah.
Sorry. So we have a lot of. I have a question actually. So we have a lot of sort of inquiries about LoRa and LoRaWAN, and there's a lot of discussion around that. How does LoRa Alliance come into the picture?
That's a great question, Rob. LoRa Alliance is an organization that standardizes all what I just said before. So thanks to LoRa Alliance, they not only promote the LoRa technology, but they also make sure that everyone uses the same standard and that those devices that we build and other people use are interchangeable and then work, and they can work together.
Thanks for that.
So I just mentioned before that LoRa uses different frequencies, and this is a topic that we have to cover because it's quite important. At the bottom of the slide, you can see the typical United States frequency allocation. And please do not try to make sense of this. It's quite complicated. But the main point I'm trying to make here is that every single country has its own frequency allocated. And this frequency can be allocated to different applications. And we have to be very careful not to use a frequency that, for example, in the United States might be allocated for the military purpose or perhaps for some mission critical applications. And that's why every single country has its own frequency, and we need to make sure that we use the correct one. And clearly, for example, if you buy a sensor that is supporting the European frequency and you will try to use it in USA, not only you risk that it might be illegal in your case, but obviously it's also not going to work. So you need to make sure that you use the right frequency.
Chris, I'm sorry to be annoying, but I have another question.
Go ahead.
So how can I know what frequency band do I need to use in my country, in my particular country, for example?
That's again another excellent question, Rob. Thank you. LoRa Alliance have essentially made a document called Regional Parameters that outlines all the frequencies that you would need to use for your country. And our team has just shared on the chat the link to that document. So if you are interested, please have a look and see what frequency should be used in your country.
Thanks.
Thanks, Rob. Okay, let's move on. So we talked about LoRa. Now let's talk a bit about LoRaWAN, so the network part of the entire LoRaWAN architecture. A typical LoRaWAN system would have 4 layers. It would have end nodes on the left side of the screen, then the gateways, the network server in the middle, and then the application server. And now I would like to focus on each one individually. Let's start with end nodes. Slide, Rob, please. So end nodes are essentially sensors and actuators. Those sensors and actuators communicate over LoRa radio frequency with gateways. And an excellent example of an end node is at the bottom of the screen. It's a LoRa-based sensor that we have developed and is meant for stock-level monitoring applications. Okay, so we have the sensor, and now let's talk about gateways. The gateway is essentially supposed to receive the data from the end node and then transform it and then forward it to the network server. The gateways are connected with the internet using 3G, 4G, or Ethernet. And the main purpose is to pass the data from the end node to the network server. There are 2 major types of gateways. There are indoor gateways and the outdoor gateways. On the bottom of the screen, you can see an example of one of the indoor gateways that the Things Network have developed. Okay, let's go next. The network server. The network server is the most important part of the entire network. It's the brain of the operation. It decides on the data deduplication. It does the routing of the messages. It takes care of the data authentication and the security. And at the bottom of the screen, you can see the examples of the network servers. For example, the Things Network, ChipStack, or a network server from Orange. And finally, we have the last element in our journey. We have the application server. The application server is important because it actually gives value to our final customer. The application server not only stores data, but also allows you to do analytics, to present the data in a way that is interesting to our customers. And at the bottom, you can see an interesting networks application servers like ThingsBoard or DataCake. Okay, great. So there is just one thing left. Let's go to the next slide. A bit of nomenclature. Every time we talk about an uplink, we mean that there is a communication from the end node all the way to the application server. If we talk about downlink, we talk about the communication from the application server to the end node. And this is one of the interesting properties of LoRa, because it not only allows you to send data one way, it is actually bidirectional. So in case, for example, your application slightly changes and you need to modify some parameters of your sensor, You don't need to go to that sensor and just change the parameter by physically connecting to it. You can use the LoRaWAN network in order to send the proper data from the network server back to the sensor to change those parameters. Okay, great. So let's move forward. We've mentioned LoRaWAN networks and the gateways, but you might be wondering, okay, but how can I access them? Where are they? This is the screenshot from the LoRa Alliance. It essentially shows that right now, as we speak, there are 156 LoRaWAN network operators in 171 countries. So as you can see, the coverage and the amount of countries that actually support this technology is quite big and is growing every day. And among those 156 LoRa network operators, there are two particular types that we have to focus on. Next slide, please, Rob. We have public network servers and the private. So a public network server is typically a network server that has everything what you need in order to start working with LoRa. Here on the right, you can see a picture of an Orange network server, the telecommunication company here in France. This kind of network server not only has all the gateways required for you to connect, but also takes care of maintenance. And essentially what you need to do is you just need to buy a sensor and you can directly connect to that network server. You don't need any other infrastructure. That's why this is the big advantage, because the entry level to start is pretty low. You don't have to spend much money. On the other hand, the disadvantage of having this kind of public network server is that you're dependent on the third-party network operator. So in case you have a problem with your application that is because of the network server, you need to deal with the third party to solve that issue. And another issue is that if you have lots of sensors, the monthly cost of operation can also grow pretty quickly. So to give you an example, our test unit in Orange costs €1 per month. But if you have many sensors, the number can go quite quickly. There is one more type of public network servers that I haven't yet shown here, which is the Things network. And this is a network server that is public, but is operated by community. So everyone can buy gateways, can connect to it, and can use those gateways to essentially transmit data. And the community creates the coverage. Okay, fine. So let's go to the next one, the private network servers. The major advantage of the private network server, as you might already imagine, is that you're not dependent on the third party. You are in control of the entire network. If something goes wrong, you have the power to fix it. And another hidden advantage is that you don't need to send data to the cloud. You can have a full on-premise installation, and if your organization, for example, does not like to send data somewhere else and they want to keep that data only on site, with the private network server, this is possible. The disadvantage on the other side of the private network server is clearly that the initial cost is quite high. You need to invest in gateways, you need to install those gateways, and you need to also maintain the entire infrastructure. That's why it's a good solution if you have big applications where you really need to take care and control the entire application yourselves. And the examples of this kind of private network servers is LoRaWAN or ChipStack, which is open source and everyone can use it. Okay, perfect. So let's move forward. We talked about the network servers, the gateways. Now it's time to talk about devices. There are three major types of devices in the LoRa world: the Class A, Class B, and Class C. Class A devices are devices which are battery powered. Most of the time in the life of such device, the device sleeps. It does not transmit any data. Once the device wakes up, it transmits a message and then waits a bit, and then it opens two reception windows. You can see that in the yellow color and the blue color on the first line on the slide. Those reception windows are essentially windows that in which the network server can send data back to the device. If the network server has nothing to say or does not manage to send data back to the device goes back again to sleep, and then the cycle repeats. And this way, because most of the time the device do nothing apart from sleeping, it can pretty well conserve the battery, and that can last even many, many years. On the other hand, Rob, slide please. Yeah. On the other hand, we have Class C devices. Those are the devices that are connected to the mains power the entire time. So they don't have any battery restrictions. And as you can see, they don't go to sleep. They first send an uplink, and then they open the reception window, then another reception window, and then they keep open that reception window for the entire time until the next cycle comes in. And this is interesting for applications like actuators. So imagine that you have a valve that you would like to control, and in case, for example, the network server decides to close that valve, because the device is not sleeping, it will receive that data immediately and then act on it. If that wouldn't be the case and the device would be sleeping, there is a high chance that you would not be able to close the valve and you would flood your house, for example. So using a Class A device for this kind of application would not be a good idea. And then at the end, we have the remaining one, which is the Class B. And as you might already guess, it's the combination of the two classes. It allows you to operate on battery. So those are the battery-powered actuators, essentially. It does go to sleep, but it wakes up with the constant frequency every some time in order to receive a potential downlink from the server. And this way, it kind of combines the two worlds. It does preserve the battery, but at the same time allows to more frequently communicate with the network server. Okay, great. So we went through the classes of the devices, and now let's go to the next part. The range. So I mentioned at the beginning of our webinar that LoRa stands for long range. But there are some considerations that you have to keep in mind in order to deploy your application correctly. On the left side, you can see urban Paris. It's essentially a very densely populated city where we have a gateway installed in the center. And you can see that the maximum range achieved in this case was 7 kilometers, which is actually quite good. And the typical range is around 2 to 3 kilometers. On the other hand, on the right side, we have the rural Geneva Lake area. And here the gateway is located also quite high above the ground, but you can see that the maximum range is 60 kilometers. And this is because there is in line of sight connection, there is no obstacles on the way. And that's why the communication allows to reach really, really big distances. And the typical range will be here around 10 to 15 kilometers. And to give you just an extreme example, there have been attempts to beat the world record in the communication with LoRa, and there has been the weather balloon sent to the atmosphere, and people even managed to reach several hundreds of kilometers using this technology without any modifications. So as you can see, the less obstructions you have, the farther you can go. And with that, I would like to thank you, and I will pass the mic back to Rob, that he will talk about applications.
Sorry, I was muted. I said thank you, Chris. Thanks very much for this great piece of education. And just now for the last part of the webinar, I'd like to give a bit of life to what we've just talked about and connect the LoRaWAN concepts mentioned by Chris to actually a real life use case we've also worked at. As mentioned earlier, one of Terabee's focus areas is level monitoring, and that means understanding field levels, either different materials stored in containers, or it can be also measuring materials in their natural form, like river levels, right? And so I'd like to talk about one of our recent projects in the level monitoring space, and particularly in the field of smart agriculture. Terabee has built a really great partnership with Brunata, who is a local Swiss-based IoT solution provider. Really, they are experts in end-to-end LoRaWAN deployments. And so Brunata was approached by an end client who happens to be a large pig farmer in Switzerland, and they were looking for ways to monitor their numerous silos in livestock farms that were storing pig feed. And so the farmer was mainly interested to answer the following three questions. How much feed do they currently have left in their silos? When do they need to order more? And how can they automate that process? How can they automate that feed delivery process without without worrying further. And of course, in order to fulfill these needs and answer these questions, there has to be a way or a system in place that measures remaining feed levels, right? And so Brunata found Terabee and also its self-powered LoRaWAN level device, which actually is exactly designed for these types of longer range sort of level distance measurement applications in silos and tanks. And so as a first step, in an office setting, Brunata registered the Terabee device with their selected network server and application, just like Chris explained before, making sure the data exchange over the LoRa is successful. Then they also went out in the farm and tested the network coverage using something called a LoRa field tester, just to make sure that radio frequency signal between the closest gateway and the place they're going to be installing is sufficient and data connection is good. The Brunata team also went out in the farm and tested, they installed the two devices right after on top of the silos on a removable hatch. Just to give you an idea, it's approximately a silo 6 meters in height and 2 meters in diameter. And after a few minutes, first data on feed levels was available on the smartphone and displayed on the very nice presentable web application. As you can see, the farmer can now see real-time field levels of animal feed in both silos, really at any time, which is provided by Brunata and powered by Terabee sensors. And also a historic view is available to better understand consumption cycles. So in the chart below, we've taken 1 month's data from silo number 2, which you can see as well is almost empty right now. And this is data that I've pulled in from yesterday, so give or take real time. And then in the graph, you can clearly see things like active versus inactive periods, feed movement in silos, exact date and time of new feed deliveries, and also when farmers need to think about ordering new feed, right? Because the levels have gone below the thresholds that they've set for themselves when they need to think about new feed deliveries. So by looking at this example at the end, we kind of want to ask, how does LoRa make our lives better, right? How does this end-to-end LoRaWAN solution really actually help the farmer and help make their life better or easier? So for one, farmers now do not need to regularly go out in the field and manually check the feed levels. This is both cost and time saved, but also it allows the staff to focus on other important parts of the business or business operations. Improving staff safety. Manual checks often imply climbing these silos and visually inspecting the remaining feed. Clearly, that can be a dangerous task sometimes for people themselves, and hence, with such LoRa-powered sensors in place, this can be completely avoided. Thinking you have more feed left than you actually do is a common pitfall in livestock farms, and so this results into last-minute feed deliveries, which often happen to be actually very, very extremely expensive, and also can put farm animals at danger, right? Because they've run out of food to eat, and so putting business at risk in general. So reducing this type of human error would put a lot of minds at ease, clearly. So studying historic consumption patterns can help us improve when we order and how we order feed. All of that is based on collected and accurate data that's coming directly from the silos. And we're not talking about opinions, we're not talking about feelings, we're not talking about any guessing. We're talking about real data at hand, and with this data in hand, businesses can thrive and then optimize further their business operations. This clearly is only one application and one example where Terabee and Brunata are actively involved. But outside our business, there are numerous other cases where LoRa is making this world a better place, either for individuals, for different sized communities, and even for different parts of the world. So, yeah, we really hope that this has been a helpful and educative session for you. Thanks a lot, Chris, for this great technical part on LoRa and LoRaWAN. And in case you haven't yet, we hope that you too will soon join the big LoRa movement. Thank you. So I think, all right, we have kind of with this, we are now opening the Q&A part. Let me just bring in and look at whether you have any questions. There we go. Just a reminder, there is a Q&A facility here in the webinar, so if you do have any more questions at this time, please share these with us. We have got a few minutes. Yeah, we have got a few minutes, so we can answer a few of them now. But please don't worry if we don't answer all of them. We're gonna come back individually to all of you in case we don't and answer them basically. Yeah, I'm checking now. Okay, so we have a question from Jose. So if I'm someone new to LoRa and want to start and set up fast and with minimum cost, which LoRa network type is best for me?
That's a very good question. So if I were new to LoRa and I wanted to reduce cost and just get started fast and quickly, I would use the Things network. It's the public server that I mentioned. And essentially, you don't have to, if you're lucky, there might be a gateway next to you, so you don't need to buy any. If you're not, then you might have to have a gateway yourself. But this network server allows you to test your application very quickly. And once you are sure that this is what works for you, then you can look for either a private network server that you would deploy yourself, or look for some other paid network servers like the previously mentioned Orange network server in France, or a Swisscom in Switzerland, or any other that is available out there in the world. Clearly, we did not mention all of them, and there are plenty. But yes, that's how I would proceed.
Okay, perfect. Thank you. Thanks a lot, Chris, for the answer. I'm reading a question from Jim. Hi, Jim. I guess it was probably for a particular slide that you were mentioning at that point. So I'll just read it out loud and then see if we understand it well. So you're saying, sorry, I lost you for a second, but you don't need to use the cloud one. Can we use it locally with our own network server?
Yeah, thanks, Jim. That's exactly the case, and it's part of the network server I mentioned, the private ones. So you can have your own private network server, Chipstack, for instance, which is open source. You can install it on your own PC at home, or a Raspberry Pi, or any other small PC, and that's already sufficient for you to run the entire LoRa network. So there's no need to send data outside. But clearly, if you have your own network, then you have to take care of maintaining it and adding gateways to it and making sure it works correctly. But yes, it's true. You can have for free self-maintained network server at home for tests, for example.
Okay, perfect. Thank you. Another question from Celine, who's asking, how secure is it to transfer data via LoRaWAN?
That's another excellent question. Thanks. So LoRaWAN has been designed from scratch with the security in mind, which means that every single transmission between the sensor and the network server and the application server is encrypted. And essentially how it works is every sensor has a set of unique keys called DEF-UIs and the application keys that are known only for that device. And those keys then have to be registered on the network server side. And if those keys matches, then the device can communicate with the network server through an encrypted session without any problem and without any risk that this data might be breached somehow.
Okay, perfect. Just looking at others. I'm sorry, we have a few, and so we won't have time to answer everything, but we'll definitely get back to you. Jesus Pestana, you're asking about the battery time for the sensor, probably that we've showcased. It depends. So if we give an update rate of one measurement per hour, you can achieve from 4 to 6 years, and that will a lot depend on the climate and the temperatures and the weather sort of you install that device. So to give you an idea, yeah, 4 to 6 years with one measurement per hour. Yeah, and then clearly we have faster frequencies and and lower frequencies. I'm sorry, I'm conscious that I'm conscious of the fact that we're running out of time, and actually we ran over a bit, and actually need to draw things to a close. For those who have reached out, like Michelle G, I can see your question here, and clearly we do have your email addresses from the registration process, so we'll get back in touch with you for one-on-one follow-up, right? So just wanted to inform that we do have a next webinar, which is on November 18th. And so if you're interested in people counting solutions or everything we do in smart buildings area, please stay tuned. We're going to come with more information, and we hope to see you there. So with that, we'll bring today's session to a close. Thanks everybody for participating, and please join us for future webinars. Thanks and bye-bye.
Thank you. Ciao, ciao.
Ciao, ciao. Thank you.